Hello everyone, this is Gas Laws Made Simple with Ms. Rodriguez, and today we're going over everything you need to know about the gas laws unit in high school chemistry. So today we're going over kinetic molecular theory, Dalton's law, Boyle's law, Charles's law, Gay-Lussac's law, the combined gas law, and ideal gas law. So starting with kinetic molecular theory. Basically, this theory just tells us how gases behave. Gases have indefinite shape and indefinite volume. They diffuse from areas of high concentration to low concentration. The volume of a gas is mostly empty space. Gas particles do not attract or repel each other, and they're in constant random motion. There's no kinetic energy lost when gas particles collide, and all gases have the same average kinetic energy at a given temperature. In order to talk about the gas laws efficiently, we need to know these three definitions. Volume is the amount of space an object takes up. Temperature is the average kinetic energy of a particle. And for gas laws, a lot of the time it has to be in Kelvin, which is just another way to measure temperature, just like Celsius and Fahrenheit. And pressure is the force per area on a surface. STP stands for standard, volume, temperature, and pressures. The standard volume is 1 liter, which is equal to 1,000 milliliters. Standard temperature is 0 degrees Celsius, which is equal to 273 Kelvin. So anytime we're trying to go from Celsius to Kelvin, all we have to do is add 273. Standard pressure is equal to 1 atmosphere, which is equal to 760 mmHg, which is equal to 101.3 kilopascals. There are more pressure units out there, but these are the ones that we focus on because they're the most commonly used in chemistry problems. Starting with Dalton's law of partial pressure. Basically, Dalton's law states that the total pressure in a mixture of gases is the sum of the partial pressures of each gas. So if you add up all of your partial pressures, you're going to get your total pressure. Now, in order to plug into the Dalton law formula, all pressures must have the same unit. If they're different units, you have to convert them so that they're the same unit first. For example, what is the pressure of a mixture of HE and Ne gas when the HE has a pressure of 480 torr and the Ne has a pressure of 290 torr? So torr is another unit for pressure. We know that we have HE and Ne, so we have to add up our partial pressures to get our total. Both of the pressures are already in the same unit, so they're both in torrs. So all we have to do is add them up. So 480 torr plus 290 torr gives us a total of 770 torr. Next, we have Boyle's law. According to Boyle's law, pressure and volume have an inverse relationship. What that means is, as pressure goes up, volume goes down, and as pressure goes down, volume goes up. And he showed that in a graph by a line that goes downwards. So downward means that they have an inverse relationship. The formula for Boyle's law is P1V1 equals P2V2. And in order for Boyle's law to apply, temperature must be constant. For our Boyle's law example, in a 20 milliliter container, the pressure is 2 atm. What is the pressure if the gas is moved to a 10 milliliter container? So plugging into our formula, pressure 1 times volume 1 equals pressure 2 times volume 2. So for our P1 and V1, we have 20 milliliters and 2 atm. For our P2, V2, we don't know our second pressure, but we do know our second volume. So equals 10 milliliters. We need to get the missing variable by itself, so we need to get X by itself. That means we need to move the 10 milliliters, and we move it by dividing, because that's the opposite of multiply. So we take 20 milliliters times 2 atm divided by 10 milliliters. So we take 20 times 2, divide by 10, and that gives us our answer, or our X, which is 4 atm. So our P2 is 4 atm. Charles's law states that temperature and volume have a direct relationship. That means as volume goes down, temperature goes down. As volume goes up, temperature goes up. And if we look at the graph, now we have a positive line or a positive slope. The formula for Charles's law is V1 over T1 equals V2 over T2. And in order for Charles's law to be true, pressure must be constant. For example, a balloon is inflated to 3 liters at 25 degrees Celsius. What volume will the balloon have if it is placed in an ice bath until its temperature reaches 0 degrees Celsius? Notice that for our first step, we have to turn our Celsius into Kelvin. So we add 273 to both of our Celsiuses, and we get 298 Kelvin and 273 Kelvin, and those are the numbers that we plug into our formula. Our V1 is 3 liters, our T1 is 298 Kelvin, equals V2, which we don't know, so let's put an X, over T2, which is 273 Kelvin. We solve for our X, and we do so by cross multiplying. So cross multiply means you multiply across the equal sign. So 3 liters times 273 gives us one side of the equal sign, equals X times 298. And we have the other side of our equal sign. We need to get X by itself. That means we have to move the 298, and we move it by dividing. So what we plug into our calculator to solve for our X is 3 times 273 divided by 298, which gives us our answer, which is 2.75 liters. So our V2, or volume 2, is equal to 2.75 liters. Gay-Lussac's law states that temperature and pressure have a direct relationship. That means that as pressure goes down, temperature goes down, and as pressure goes up, temperature goes up. If we look at our graph, it's a very similar graph to Charles's law, so we have a positive line or a positive slope, and it also has a similar formula. So P1 over T1 equals P2 over T2, and for Gay-Lussac's law to apply, volume must be constant. For example, a gas has a pressure of 100 torr at 25 degrees Celsius. What will the pressure be if it is heated to 298 degrees Celsius? Again, just like before, we turn our Celsius into Kelvin first, so we add 273, which gives us 298 Kelvin and 1201 Kelvin, and those are the numbers we plug in for our T's. For step 2, we plug in our P1 or our pressure 1, which is 100 torr, over T1, which is 298 K, equals, we don't know our pressure 2, so there's our X, over T2, which is 1201 Kelvin. Just like before, we solve for our X by cross multiplying. So 100 times 1201 equals X times 298. To solve for our X, the 298 has to move, and we move it by dividing. And what we plug into our calculator is 100 times 1201 divided by 298, which gives us our X, which is 403 torr. So our P2, or our pressure 2, is 403 torr. Just as a side-by-side comparison, these are the relationships and the graphs for all three laws we've covered so far. Notice that Boyle's law is the only one with an inverse relationship and a negative slope. Charles and Gay-Lussac have a direct relationship and a positive slope. The combined gas law puts all three of our laws together because in the combined gas law, all three of the variables can change. So the pressure, the volume, and the temperature can change. The only thing that has to stay constant in order for the combined gas law to apply is the moles of gas. So you can't add or take away the amount of gas. Let's practice using the combined gas law formula. A gas balloon has a volume of 106 liters when the temperature is 45 degrees Celsius and the pressure is 740 mmHg. what will its volume be at 20 degrees Celsius and 780 mmHg? Just like before, we turn our Celsius into Kelvin, so we add 273, which gives us a temperature of 318 K and 293 K. We plug our numbers into our formula, so P1 V1 over T1, P1 being 740 mmHg, V1 being 106 L, and T1 being 318 K, equals P2 V2 over T2. P2 being 780 mmHg, we don't know V2, so we're going to put an X there, over T2, which is 293 K. Just like before, since we have fractions, we have to cross multiply. That means we're multiplying 240 times 106 times 293, and that gets us the left side of the equal sign, equals 780 times x times 318, and that gives us the right side of the equal sign. We have to get x by itself, so that means the 780 and the 318 have to move. We move them by dividing. So what we're going to plug into our calculator to get our x is 740 times 106 times 293 divided by 780 divided by 318, and that gives us our answer, which is 93 L. So V2, or volume 2, is equal to 93 liters. Avogadro's principle applies to the ideal gas law, and basically what Avogadro's principle states is that volumes of gases at the same temperature and pressure are going to contain equal numbers of particles. So if we look at the oxygen gas versus the hydrogen gas versus the water vapor, they're all at 1 atm and 273 K. And if we look at the number of dots, they have the same number of dots, representing that there's the same number of particles in each of these boxes. The formula for ideal gas law is PV equals nRT. And out of all of the gas laws, this is the one that's the most specific. That's because each of the variables have to be in a particular unit before you plug it into your formula. Your P, or your pressure, has to be in atm. Your V, which is your volume, has to be in liters. N stands for the number of moles, which is the grams per mole. If you only have grams, you have to turn it into moles first. And remember, that means you have to take the grams you're given and divide it by the molar mass, and that's how you turn it into moles. R is a constant, and as long as P is in atm, the number for R is always 0.0821. And T, just like all of the other gas law formulas, must be in K, or Kelvin. For example, a rigid container with a volume of 20 liters is filled with nitrogen gas to a pressure of 197 atm at 28 degrees Celsius. How many moles of gas are present in the container? Let's check that all of our numbers are already in the correct unit. P has to be in atm, so 197 atm, that one's good. V has to be in liters, so 20 liters, that one's good. N is missing, so that's going to be our X. R is always going to be 0.0821, it's a constant. And T has to be in Kelvin. 28 degrees Celsius is not in Kelvin, so we have to change it. So step 1 is going to be to add 273 to our 28 degrees Celsius, which gives us 301 Kelvin. Now that everything is in the correct units, we're going to plug it into our formula. So P equals 197 times V, which is 20, equals N, or X, whichever you're more comfortable with, times R, which is 0.0821, times T, which is 301. We're going to solve for our X, or solve for the N, and we do that by moving the 0.0821 and the 301, and we do that by dividing. So what we're going to plug into our calculator to get our X, or to get our N, is 197 times 20 divided by 0.0821 divided by 301, and that gives us our N, which is equal to 159 moles. All right, that is everything you need to know for the gas laws unit in high school chemistry. Thank you so much for your time. Let me know if you have any questions in the comments below. If you found this video helpful, make sure you hit that like button and subscribe so you don't miss any of my future chemistry content. If you're a chemistry teacher and you would like access to this exact PowerPoint, it is in my TPT store called Chemistry Made Simple, as well as worksheets, labs, and activities that align with this unit and all other units of high school chemistry. I hope you have a great day. Bye!